Any geometric sequence can be written with both an explicit and a recursive formula. The recursive formula is useful for finding the next term in the sequence. The explicit formula is more convenient when finding the nth term. Problem 2. Finding recursive and explicit formulas. Find the recursive and explicit formulas for the sequence 7, 21, 63, 189, and so on. We can immediately identify the starting value, a sub 1, is 7. The common ratio, r, is 21 divided by 7. Note that's our second term divided by the first, and that's 3. So we'll use the formula. First, the recursive formula. A sub 1 equals a sub n equals a sub n minus 1 times r. Then we'll substitute the starting value for a sub 1. Well, we know that's 7, so a sub 1 equals 7, and a sub n equals a sub n minus 1 times r. Next, we'll substitute in the common ratio we found earlier. That's 3. A sub 1 equals 7, and a sub n equals a sub n minus 1 times 3. So the recursive formula is a sub 1 equals 7, and a sub n equals a sub n minus 1 times 3. Take note the recursive formula always includes two components, stating the initial term a sub 1, and then providing the formula which builds upon a sub 1. Alright, and now to find an explicit formula. Well, we'll start with the explicit formula in its general form. A sub n equals a sub 1 times r raised to the n minus 1 power. We'll substitute in our starting value in place of a sub 1. So now we have a sub n equals 7 times r raised to the n minus 1 power. Finally, we substitute in our common ratio, 3, for r, to arrive at a sub n equals 7 times 3 raised to the n minus 1 power. So the explicit formula for this same sequence is a sub n equals 7 times 3 raised to the n minus 1 power. Your turn. Part A. Find the recursive and explicit formulas for the sequence 2, 4, 8, 16, and so on. And Part B. Find the recursive and explicit formulas for this sequence 40, 20, 10, 5, and so on.